Right, let's get started. Thank you very much for everyone for deciding to spend your next 20 minutes with me. Hello as well to everybody online or who's logged in downstairs connected to this session, and to the people who might be viewing this later on. We've got a lot of information to get through today and only 20 minutes to do it, so I'm going to be going about Warp 5, so hold on to your hats. Just a quick safety brief before we get started. I am going to have to insist that all chairs and tables are in the upright position. We've not got to the party yet, so yeah, just make sure those are upright. In the event of emergency, tea and coffee are available downstairs, and hopefully some more of those little pastry things. They're quite nice. You can also assume the crash position. That is, put your hands on the desk or the chair in front of you, put your head on your hands, and that should get you through the rest of the session. It's okay, it's Friday afternoon. I'm not going to judge. So let's get cracking. First of all, who am I? My name is Ray Ellingham. I will be your captain today. I'm assisted by Aaron Felton, who is my co-pilot. In the event that I cannot continue your flight, he will be taking over. We are from Red Olive. Red Olive is a consultancy that focuses on being able to extract and maximize the benefit of the most valuable asset that any business owns, which is, of course, their data. We have hundreds of years of data expertise collectively between us, and it's from that knowledge that I've extracted our top 10 transactional database mistakes, along with some suggestions of how they could have been avoided. This is a beginner session, so don't worry, I'm not going to get too technical, because we don't want to do that on a Friday afternoon. I'm going to cover some basics as well. So let's just go over what do I mean when I say transactional database. So in business, I mean, you can have a lot of complexity. We've seen a lot of different things over the last few days, but normally there are two distinct types of database you find. You find your transactional database and your relational database. The transactional database is the one that's hooked up to the application. So that's one which has a lot of users, but they're doing very tiny changes. They're updating one record, they're deleting one record, that kind of thing. And then you've got your relational database, which has just got a few users, but they are bringing back a lot of data so that they can aggregate it and then put it into reports. Optimally, you would normalize the data for your transactional databases and denormalize it for your relational databases. And again, if you don't know what that means, don't panic, because I will go over it in a bit more detail. Now, the three main issues we are going to be trying to avoid for our transactional databases for the mistakes is the issues with integrity, security, and maintenance. So problems with integrity, that's things like data inconsistencies. That can affect your reporting and your analysis. People start to lose trust in the data, and then you start having compliance issues as well. For security, that's obviously big things like data breaches, that's identity thefts. You know, these are things that obviously no business wants to happen. You can have reputational damage if you start losing your data, and you can have legal liabilities kick in as well. And then finally, we've got maintenance. This is the ones that obviously the devs don't like. Difficulty in modifying the database structures, problems with accessing the data, and problems with performance and stability. So these are the three main things that we are trying to avoid by designing our transactional databases carefully. So let's begin our countdown. At number 10, we have normalization. So what is normalization? Normalization is the process of designing a database to reduce redundancy and improve efficiency. Normally, it involves splitting a large table into lots of smaller tables and then defining the relationship between them. This has been formalized into what are called normal forms. Now, there are more normal forms than what I've listed here, but you're ideally going to get to the third normal form for your transactional database. Each rule has the rule of that level and the ones before it. So second normal form is going to be the rule you can see there, and also the rules that are in the first normal form. And if all of that is just complete gibberish, don't worry, we're going to walk through a really, really quick example. So here we have some data that is freshly stolen from the SQLBits website. It's obviously the year that SQLBits happened and where it happened. And you can see we've got some comma delimited data in there, and we've got a bit of inconsistency. You've got London, England twice, but the spaces are different between the two. So let's take it to first normal form. And literally all we're doing there is splitting it into that comma delimited list into two separate columns. So we've got the data is cleaner and it's available there, but we've still got some duplication. You can still see London, England twice. So let's go to second normal form. We pull that data out. You can see I've got a destination code here, which is my key. Sometimes, or normally that would be an integer, but I've put it here as text just so it's easier to see. And you can see now we've only got 3 copies of the destination, so London, England isn't duplicated. But England is. England is listed twice there, so let's take it to third normal form. So we pull that out, and now we have a country table as well, and you've got England and Wales just appearing once. But why would we do this? So it's, why not just leave everything unnormalized? It's not as obvious with these small amounts of data, but if you start looking at really big amounts of data, you see a big reduction in data redundancy by putting your normalization in there. It also helps improve the quality. because it ensures that your data is consistent. If you need to make a change to London, say we decide to rename it to something else, then you can just change it in one place and all your data will change at the same time and be consistent. So yeah, normalization, that's number 10. Let's go to number 9. Identity issues. So each table in the database should have an identity column that is automatically populated with a unique value. Sometimes this is a GUID, sometimes it's an integer. But let's look at an example of why we should do that. So let's say that next year SQLBits decides it's going to go to Birmingham. Great, Birmingham, middle of the country, lovely place. But then you see this data in the system. What does that mean? Does that mean that somebody's accidentally entered it twice? Quite possible. Or does it mean that the event in the spring was so popular, they're going to run it again in autumn? Well, that would be awesome. But we just don't know. Whereas if we have an ID column in there, it doesn't make it completely clear, but it makes it a little bit clearer as to what's going on, as to whether it's definitely a duplicate or whether it's, there are legitimately 2 rows of data in there. The other thing I just want to make, to highlight with identity is naming. We need to be careful when we name things. In the example you can see here, you've got your destination ID, but what does that relate to? Does that relate to your airport table or your country table? By naming it carefully and lining it up, it makes it much clearer, so that people are going to be doing their joins correctly, so that you're going to be able to have your data pulled back correctly, so reporting gets much easier as well. So yeah, that's number 9. Let's move on to number 8. Hard deletes. So not all businesses have lakes and lake house. If you say some businesses, have you got a lake? They'll start thinking about that time the dishwasher broke and the kitchen was flooded. A lot of them still have very, very simple setups where you've got an application with a database behind it going to reporting with a database behind it and this sort of, ETL process in between it, which is normally just, copy some data across from one to the other. And the problem with that setup is when you need to delete some data from the application. You get places which literally just go and delete the data out of the table. And the problem is then that your ETL process has no idea what's happened and you've just lost all integrity in your reporting. So that's not where we want to be. So if you are in a very simple setup, you need to start looking at, well, what can we do to avoid that situation? And there are many ways you can do this. I mean, if you do have the luxury of going into your boss's office and saying, right, I'm going to introduce a lake or a lake house, I'm going to start using Delta Parquets, I'm going to keep histories of data, great. A lot of them are going to look at you and say, the budget doesn't allow for that. So what else could we do? In these cases, you could look at doing a soft delete. So that is having a column in your transactional database, which is either a bit or a Boolean or a date time, and then filling that in to say when a row's been deleted, and changing your application so that it takes that into consideration, and it just doesn't display those records. Then you can have an out-of-hours process to go and clear that data out. Or you could have change tracking enabled, which keeps a log of everything that's happened, and then takes that across. So here you might have something that looks a little bit like this. A row alerts it's being deleted. That message is flown across to reporting that says, yep, I've got it, it's been deleted. Then you can either clear out the data, or it may have been cleared out already. So yeah, that's a better way of doing it. And then on to number 7. Now this is a very, very simple one. Date times. It's surprising how many places don't have columns in their tables for when the row was created and when it was updated. And this is very valuable to have in your transactional tables. It adds context for the data. It also supports various operational and analytical needs. It's also very useful for things like auditing and GDPR. And it really doesn't have much of an overhead to put that in. So it's a case of just get those columns in there and you're sorted. It makes it so much easier. On to number 6. Constraints. Now there are several ways of constraining data in SQL. One is to use restricted date types. Another way is to use a column constraint. These have a crucial role to play in maintaining the data accuracy and integrity. It's therefore surprising that they're sometimes neglected. There's a lot of places where they just say, right, now everything's an mvarchar in your database and all the constraints and all the checks are done in the application. And you absolutely can and should put checks in your application for the data. But you can also put some critical checks in your database layer. Things like making sure that you've got numeric date types, things like disallowing nulls, or putting default values in. These are all valuable in helping to maintain your data integrity. But don't go overboard. Don't go back and suddenly think, I'm going to put constraints everywhere. I'm going to constrain absolutely everything, because there is an overhead to that. And you will start having performance issues on your database if you check everything. So just check the key details. On to number 5, triggers. So triggers, they can be very useful. They're automatic processes that run based on things that happen. But they must be used wisely. If they're used wrongly or to excess, they can cause performance issues for the database. They can also be a bit of a maintenance headache. So let's look at an example. Somebody goes ahead and deletes a row. That's fine. And maybe that triggers an insert to another table, things like an audit. That's perfectly normal. Maybe it also triggers some updates to go and redo some aggregations. Then you get some bright spark who thinks, I know, from that update, I'm going to trigger a delete. And then you start having the DBA running down the corridor towards you screaming. And it's not a place that anybody wants to be. So a better idea here than being over-reliant on triggers might be to look at using something like CRUD sprocs. And if you don't know what I mean by that, don't panic. I will go over that in a bit more detail shortly. But first, we'll go on to number 4. Chain down. So what am I talking about here? I'm talking about hierarchies and self-referencing tables. Things like, you can see the hierarchy I've got here with the SQL bits events. Anyone going to the Friday night party tonight? Yeah, a couple of people, yeah. There's going to be some events happening there. So you've got your Friday night party, and then obviously things happening at that party. You've got some interactive games, some street food, a bit of fancy dress, and of course the bar. So that's useful data to have. And then on the right-hand side, we've got our flow diagram. So here that tells you what you should be drinking. I'm afraid it's not quite 5 o'clock yet, but we're not far off. So by the time the session finishes, you'll be nearly there. So the reason we need to have this is because the data, if you store all of the logic for how this data relates to the other data in your application, people who are just looking at the data, things like reporting, is going to really struggle because they have no context for what's going on. So you need to be careful how you're designing these. It's a bit difficult to go into exactly how to do that because there are so many varied scenarios based on the data. But if you've not heard of hierarchy IDs before, that's definitely something worth looking into. And yeah, just design it so that the data makes sense and it's not just, thrown in there any old way. Let's move on to number 3. Indexes. Now, as sure most of us know, too many indexes are just as bad as too few indexes. If you've got too many, you're going to have so many copies of your data that it becomes a bit of a performance nightmare every time you need to add or update it. On the other hand, if you don't have enough, then you're going to have really bad performance every time you're trying to select that data. What you want is the Goldilocks of indexing. Now, I could stand here and speak for hours about this, but what I suggest you do is find a DBA at the party later, give them a drinks token, and ask them to tell you all about their indexing strategy. It will be riveting. You're going to love it. But in the meantime, let's move to number 2. Cursors. So what is a cursor? Cursor is a piece of code that processes the data set row by row. It's also known sometimes as a while loop. It can be useful in really specific circumstances, but in general, they're best avoided, especially for moderate or large volumes of data, because SQL is basically designed for and operates most efficiently with set-based operations, i.e. working with the entire result set at once. I mean, here you're getting a list of rows, looping through each row in turn, updating each row, and then done. That's your while loop. On the other hand, you could just tell SQL to update every row, and then it's done. After all, why would you have just one plane when you could have all of them take off at once? Sounds like much more fun to me. Which leads us to number 1, dynamic SQL. So this is when a choice is made to write SQL dynamically instead of statically. So dynamic SQL constructs the SQL queries at runtime. So this means that you can be more flexible. You can insert table names and column names into there. It can be sort of, very varied in what it's doing. Meanwhile, static SQL is just you're fixed. You've got that table, that column being selected. Now, while dynamic SQL can be very flexible, it can cause performance problems. It can cause a bit of a maintenance nightmare, and it can cause security issues. The big one here is SQL injection. So SQL injection is where somebody sneaks sort of malicious code into the application layer and then sends that to the underlying database. Best case scenario, they're just going to access some data that they shouldn't have access to. Worst case scenario, they're going to be able to potentially compromise your entire server. So again, this is another thing dynamic SQL can be useful, but be really careful with it. Instead, again, CRUD sprocs might be the way forward. So let's go over what do I mean by a CRUD sproc. So CRUD stands for create, read, update, and delete. So create is obviously a select statement. create is an insert statement, read is your select statement, then you've got update and delete. They are the 4 basic actions that you're likely to be performing on data in a database. By having this code in a stored procedure, performance is improved after the first run because the execution plan can be cached. So this means that SQL remembers what it did last time and can do it more efficiently next time. It also decouples the database logic from your application, which helps prevent the SQL injection problems that we were talking about earlier, which improves the security of your estate. And finally, by using the CRUD sprocs, it helps to ensure consistent data access. So you've got the sort of the same operations happening across the board. And yeah, that brings us to the end of our top 10. If you're only going to take a picture of one slide, this is the one to take a picture of, because this summarizes everything. We have learned that we need to normalize our data, preferably to third normal form. We've learned to have well-named ID columns containing unique values. We've learned to use soft deletes and change tracking. We've learned that we should include created and updated timestamps. We've learned to have just enough constraints and indexing. We've learned that triggers, cursors, and dynamic SQL should be used sparingly, and that we need to be clear when we're generating chains or flows of data. And we've learned to use CRUD sprocs where we can. And if you'd like to keep your cameras out, there's the feedback form. I would very much appreciate it if you could give me some feedback today. It is my first time speaking here, and I'd like to know whether I apply to speak again next year or whether I go back to being a delegate. But more importantly, you could win a fabulous prize, just a few radio buttons, and then go down at the end of the day to the main hall, and they will be calling out somebody who's won a prize for filling in feedback forms. So really easy, much easier than trying to land a plane. Oh yes, you get to choose a charity as well when you fill in the feedback form, so charities benefit as well, so there really is no reason not to. And I've got like a couple of minutes left for questions, or you're more than welcome to come and find me at the end and ask me my indexing strategies. Back one slide, there you go. Yeah.